Okay, here we go. 2-9. So I would like you guys to tell me, this is me personally how I like to graph an x cubed. Okay? So first off, we all get the idea of what the x cubed basically looks like. What does he look like? They're doing an alright job there. It's not too shabby, right? You okay with that? Okay. So what kind of things do we have for transformations? Can anybody talk to me about it? Compression. So good compression. Where does the compressions come in? Because it can be a compression or a stretch, we can say, right? Where's that value if I wanted to have it? The number in front of x cubed, right? So like, if I had it, it'd be like a parentheses x minus h quantity cubed plus k. You would have it written like that. There's some more in there even than that. But the a value would compress or stretch it, right? Does that make sense? Okay. What does the h value do in that? Is it a vertical shift or a horizontal shift? The h value dictates a horizontal shift, right? Now in this case, I'd move everything to the right h units, wouldn't I? Okay, what does the k value do? That is a vertical shift, right? Right? Everybody there with me? Okay, now, I know other teachers do it differently. I'm going to show you my way really quick. You guys want the hardest thing you can see straight out, or you want me to go right into it? Guys, be honest with me. What do you want me to do?
Let's do hardest thing straight out, like synthetic.
Okay. I can do hardest thing. I think if we do the hardest thing out, and then you guys, if you have questions, I will help step by step. Is that okay? Yes, Bryce. No problem, brother. The A helps us do a vertical or a vertical compress or stretch. So, like here's our U, right? So if it's like a 2, what does it do? It's steeper, right? Because it stretches it. Now if it's like a half, it makes it fatter. It takes a lot more x values to increase my y value. Whereas with the 2 out front, it takes a lot less x values to get me higher. Does that make sense? Everybody good with that? Okay, here's the nastiest thing you're going to see. What do you guys want? Squared, a cube? Cube? That's as nasty as you're going to get. That's pretty intense. Okay? So, the only thing different that I didn't talk about right there is the B value, which is also, it's a horizontal compress and stretch. Okay? So the first thing you guys got to do, I don't know if Miss Merkley or Miss Feathers or Miss Spangler, those were the 3 last year, unless you're at a different school, taught you, but you should pull out that 2 looking like this first. Because that's what's in common. Even if they weren't in common, like if I had a 3 here, guess what I still have to pull out? I have to pull out a 3 and that would become a 4/3. Even if they don't have it in common, you got to pull out that coefficient in front of you. Does that make sense what I'm saying? Yes, no? The reason why that does that is because instead, like I said here, there is a horizontal compression. So I personally like to do the horizontal compression first and then shift it. Some people can do it as this and do the shift first and then compress. I like to compress and then shift. Hence why, like I said, it might be different than what people thought. This helped me in my mind frame to do it the better way. Okay, now I can show you visually and I can show you graphically. I'm not a visual person. How many of you guys are visual people? I just want to know. That sucks. I'm not a visual person. Okay, graphs I could care less about. I like to see that's how I look. But I can show you as we go along and still, but I'm going to do a rough sketch of it. Is that okay? All right. And if you do it with a graph, please be accurate. That's the key thing I would like you to do. Does that make sense to you? Okay. So what I like to do is I start with my basic parent function, x cubed. Is everybody there with me? Okay, what's some nice values for x cubed? Oh, negative 2 gives me negative 8. Negative 1 gives me negative 1, 0 gives me 0, 1 gives me 1, 2 gives me 2. I just plugged in those x values and got some y values, right? Negative 2 cubed is negative 8, negative 1 squared is negative 1, so forth. Okay, basically, like I said, this graph looks like this. Okay? Anybody have a question there? Okay, order of operations. What would I do first? Inside the parentheses. I don't care about the outside stuff until I'm done with the inside stuff. Okay? I'm going to actually do this first, this 2 right here. Now, even though I should work inside that parentheses, this, like I told you, the way I had to learn it and the way it made sense for me, I had to do my compressions before I moved vertically. Okay? Alright, so what I'm going to do is, if you'll notice, even though that says a -2, what does that -2 do on our graph? It shifts it the opposite way of what we're seeing, correct? And the reason being is what value gets me back to 0? What x value gets me back to 0? 2. And hence why we went to the right 2 instead of left. Does that make sense? But as we see just logically here, it's opposite of what we see. So instead of timesing by 2, what do you think I'm going to do to my x values? Instead of timesing by 2, I'm going to divide by 2, or what's another thing saying for divide by 2? Times by a half. Just times by a half. Isn't dividing by 2 the same thing as timesing by a half? So therefore, I'm going to times my x's or my y's. On the inside, does that involve your x values or your y values? X values. Does everybody understand that? So therefore, he's no longer negative 2. What is he? He's negative 1. And he would still give me that same x value, that same y value. This is basically what I'm at right here. That graph. Okay? So therefore, notice I plug in negative 1. 2 times negative 1 is negative 2. Negative 2 cubed is, makes sense what I did there? So therefore, this would be negative a half would give me negative 1. 0 would still give me 0. 1 half would give me 1. And 1 would give me 0. Does everybody understand where that graph came from? Notice, was that a stretch or was that a compress? There was a horizontal compress. We went from larger x values to smaller x values to get the same y value. Does that make sense? Yes, ma'am. This is just you okay there? And then once again, that graph, guys, what does that look like? Basically a little bit steep. Because we compressed our x value. Yes, no? Everybody there? So the next thing I'm going to do is I'm going to do this whole part. So the difference between this and this is the shift. So what am I going to do to all these x values? I'm going to shift them which way? To the right 2. So therefore, I'm doing this now. That's a right by 2. Does that make sense? Yes, no? Help me out, guys. I understand if I don't know, I just go on. Take this compressed value and shift it to the right 2. So therefore, this would be 1 would give me negative 8. And if when in doubt, what could you do? Plug it in. 1 minus 2. Negative 1. Negative 1 times 2. Negative 2. Negative 2 cubed. I'm basically plugging and chugging, but just using shifting instead of plugging and chugging, right? Does that make sense? Everybody there with me? Okay, and then notice, then I'm at negative, I got to move negative a half over 2. That's going to be 1 and a half. Do I want to see 1 and 1 half? That's 3 halves. Does everybody understand where 3 halves comes from? Negative a half plus 2 is 1 and a half. 2 times 1 is 1. 1 plus 1 is 3. I mean, 2 plus 1 is 2, 2 plus 1 is 3. I just made my own math up. And then notice he'd still be negative 1. 0, I move to the right 2, I still get 0. A half, I move to the right 2, that's 2 and a half, which is 5 halves. I still get 1. 1 moved to the right 2 would be 3. 3, when I plug that in, would give me an 8. Notice what would that do to my graph? He's still steep, but just notice he moves over like that, right? You guys see the visualness of what's happening as well? For those visual people? All right, sir. No, this already compressed. This already was here, right? So from here to here, what's the difference? We move to the right. So basically, I'm going step by step. I had my original, or what we call our parent function, right? I compressed the x values, then I took those compressed x values and shifted them to the right too. I am now done with my x values. These will never change the rest of the time. Because I'm done. I've completed all the x things I need to do. Does that make sense to everyone? Okay. So with that being said, I have that chart again. I'm going to have it. Give me 1 second. This was our chart. That was negative, that was 1, right? Yeah, 3 halves, 2, 5 halves, 3. So that was negative 8, negative 1, 0, 1, and 8. Okay. That was the last chart we had. So from there, now what do I do? Do I shift it up and down, or do I vertically stretch it or compress it? I do the compressing and stretching because order of operations tells me to do my multiplication before my addition or subtraction, correct? Okay, what number was that? It was a negative 3. And notice, guys, see what I do? Why do I keep doing these charts? Because all I'm saying is, what's the difference between this guy and this guy? Now, could you do everything in one thing? Sure. Could you mess that up really easily? Yes. Hence, I'm taking it a piece by piece. Does that make sense what I'm doing? And then all I say is, what's the difference from this guy to this guy? Oh, I'm going to go ahead and multiply my x's or my y's by negative 3. My y's, because it's outside of the function. So therefore, it's your y value. So I'm going to keep these guys. Like I said, I'm going to keep them. Right? Yes.
Okay, so if it's the horizontal compression of the y,
Exactly. So if you notice, like when we did our vertical shifting, it did exactly what you see. Up and down, right? It's the plus 2 to go up. But on the inside, it's opposite of what you see, right? So just treat it like that the whole thing. Anything on the outside, that's your y values. You do exactly what you see. Anything on the inside is your x values, and you're going to do opposite of what you see. So if we see times by 2, we times by half. And the reason being is it doesn't take as large of an x value anymore to get to what the other value did, because I'm times by 2. So therefore I cut the x value in half, because when I times by 2, it came back to the original thing. Does that make sense? Yeah. You got a little working with that? Hi, Chandler. Stuff. There. And then, sorry. Here we go. So I'm just going to times all these guys by negative 3, right? So therefore that became 24, 3, 0, negative 3, and negative 24. So instead of, once again, he looks like this, 1, 2, very like that, right? Now he's even taller, but he goes like this. He flipped, right? And he's even steeper now because he's stretched, right? Does that make sense, Nicole? What's our last thing? I'm so sorry. Plus 2? Minus 2. So therefore, does my x values change? Yes or no? No, so I still stay okay. 1, 3 halves, 2, 5 halves, 3. But I'm going to drop every 1 half. Because it's a minus 2, I'm going to drop everybody down 2. So that's going to be 22, 1, negative 2, negative 5, and negative 26. Notice I still have the same distances. This was a drop of negative 21. This is still a drop of negative 21. Think fun? This is a function. This stuff is exactly the same thing we just did. Onward. Okay. That's why it's benefit to be in class too. Okay, so y, let's say I had this. Ooh, I like that one. That's a 4. I made a 2 into a 4. That's a 4. That's a 4. 4. It doesn't matter? I said a 4!
In the parentheses.
Oh, that's a 3. I was being a little Thorsy. That's a 4 and a 3. Make sure they heard that stuff. Hey, so what if I wanted you to find the zeros of this? How many of you guys want to go factor that crap out and then do the way I've taught you? The zeros, what do we know? Y is 0. Right? Then we just solve it, so we add the 1. Notice on this, I'd only ask you for the real zeros. Okay. Then what do we do? Divide by the 2, right? Any questions there? Now what do we do? So therefore, how do I get rid of a 4th root? I mean, something raised to a 4th. Take the 4th root. Now this is something tricky here. I just want to make sure because I took for granted last time. So what's the 4th root of 1? 1. Okay, the 4th root of 2. Do I like radicals downstairs? So I need to rationalize this radical. I have 4th root. How many 2's do I have in there? I have 1. How many more 2's do I need? 3 to get to 4, right? Add 1, I need 3 additional to get to 4. So I'm going to 4th root of 2 cubed, top and bottom. Why am I doing that? Because now I have 2 times 2 to the 3rd, which is 2 to the 4th. And what's the 4th root of 2 to the 4th? 2. So this is now the 4th root of 2 to the 3rd over the 4th root of 2 to the 4th. And notice when you have 4th roots, you're looking for groups of 4. Do I have a group of 4? Yes. I do. So therefore, this is the 4th root of 8 over 2. I rationalize my denominator. Make sense? And that equals x minus 3. And then what do? We add the 3 over. We could get a common denominator. Everybody see where that comes from? Plus the 3. Thank you. And therefore your answer would be the 4th root of 8 plus 3 all over 2. Oh, excuse me, I need plus or minus here. Because I took an even root. Even root, you got to do plus or minuses, right? And there's some answers. Nope. That would just be, no. They're not underneath the same radical. Oh, thank you. I am a horrible math teacher today. And forever and ever.
Well, that only gives us 2.
I don't use it. But I don't. Okay. All right. Now here we go. I'm going to record this. So on number 20, notice it has the point negative 1/4. And it told me my parent function was x cubed. So how did I get from my vertex of being 0, 0, or that hump point, right? Does that make sense on an x cubed? How did that get from 0, 0 to negative 1/4? Well, I know for sure that it went to x plus 1 cubed and a plus 4. Everybody understand that? So what are we missing? Well, it probably stretched, didn't it? So I'm going to put that number a here equals y. Now, how am I able to find this? Okay, what you're going to do is a system of equations. See how I have 2 extra points? Yes, no? Okay, so I'm going to plug in 0, 5. 0 for x, 5 for y. 0 plus 1, 1 equals 3. I mean 1 cubed. 1 times a is a plus 4 equals 5. Give me 1 second, guys. And I believe a would be 1, right?
Yeah.
So therefore, that's how I would get there. Does that make sense? Okay, so once again, write the generic, plug in another point for the x and y, and solve for a, and that's how you can get the generic other form as well. So actually, yeah, do those things. Say what?